Welcome to today's video, where we shall be treating integration of trigonometric functions. In the previous video, we had done integration of polynomial or algebraic functions. So let us recall the following. Recall that if y is equal to the sine of x, then if we differentiate this, the y over the x, what do we get? We get cos x. Since we have said that integration is the reverse process of differentiation, it will now imply that if we integrate cos x with respect to x, what do we get? We get sine x plus our constant of integration, c. So the integral of cos x dx is equal to sine x plus c. Also, if y is equal to cos x, and when we differentiate this, we have what? Negative sine x. So if we integrate sine x with respect to x, what do we get? Sine x will give us minus, will come this way. So we have negative cos x plus c. Our interest is sine x, not minus sine x. So sine x will give us negative cos x plus what? Plus c. And finally, we should recall also that if y is equal to what? The tangent of x tan x, then what do we get? When we differentiate y with respect to x, we get what? Sec squared x. We have done all this integration in our previous classes, and I'll leave the link below for you to check out. So the y dx is sec squared x. So it follows that when we integrate this function, sec squared x with respect to x, what do we get? We get what? Tan x plus c. So these are the three basic, trigonometric functions whose integral we just have to, take note of at all times, which are that the integral of cos x with respect to x is what? Sine x plus c. The integral of sine x with respect to x is negative cos x plus c. And finally, the integral of sec squared x with respect to x is equal to tan x plus c. Now, we shall delve in a little bit further to take one or two examples of cases where these functions cos x, sin x, and tan x maybe are what? Are composite functions or functions of functions. So, our very first example is the integral of 3 sine into 3x plus 5 dx. I want to integrate this. So how do we start? So 3 is a constant. I always like to take my constant out. So 3 into the integral of sine 3x plus 5 with respect to x. Now, let's imagine that this problem was that of differentiation. We have sine into 3x plus 5. And you're asked to differentiate this function. What would you have done? Would have used a chain rule. Yes, we would have used a chain rule, or what we call a function of a function. If you recall, in our chain rule class, we had explained that is a function sine x carrying another function inside of it, which is what? 3x plus what? 5. And the chain rule, how do we start? We say let the inner function 3x plus 5 be u. Also, in this integration, we shall use a similar approach. So we shall say let u be that inner function again, 3x plus what? Plus 5. Yes, we start this way. And once you've called out this function to be u, we now say dy over what? Sorry, du rather over dx, because this is u. So du dx will be what? Will be what? 3. Differentiate 3x, you get 3. Differentiate 5 is a constant, you get 0. So du dx is equal to 3. What you now do here, and that's where the difference comes in. You have dx. You have du dx equal to 3. At this point, you now make dx here the subject of this small equation. So let's do it. This is 3 over 1, right? So if we cross multiply, what do we get? We get dx times 3 is what? 3 dx equal to du times 1 is what? Is du. Now to make dx the subject, divide both sides by 3. And what do we get? We now get that dx is equal to du over 3. we have just made the x the subject of this, integral. So let us call that integral star. So if we go back to star, what do we get? This becomes 3 into sine. 3x plus 5 is now what? U. Because u is 3x plus 5. Sine u dx. What is dx now? Our dx is nothing but what? Du over 3. So this is du over 3. So 1 over 3 is a constant. So I take the 1 over 3 out. Out here we have, there is 3 already here, divided by this second 3. Integral of what? Sine u with respect to u. So our integral now becomes the integral of sine u with respect to u. So this gives us, so 3 over 3 is 1. Now from what I've done earlier, we said that when we integrate sine x, what do we get? We get negative cos x plus c. So in a similar fashion, when we integrate sine u, we get what? Negative cos u plus our constant of integration, what? C. And remember that we were the ones who introduced u to be 3x plus 5. So if we go back to what u was initially, we have negative cos, what is u? Our u is 3x plus 5. Negative cos 3x plus 5 plus our constant of integration, what? C. And that gives us the integral of 3 sine into 3x plus 5. The trick we're using here is similar to that which we used in function of a function, which we call the Leibniz rule then. For the second example, we wish to integrate cos into x over 3 plus 2 with respect to x. Once again, we shall proceed, like in the previous method. Example rather. So we say let, call out the inner function, if you like, say v, let v be equal to what? X over 3 plus 2. And once you've done this, you now differentiate with respect to x. So dv dx gives us what? dv dx gives us 1 over 3. Since 2 is a constant, that is just 0. Like we did before, you now make the x the subject of what? This equation. So if you do that, you're going to have, so dx times 1 is dx equal to dv times 3 is 3 dv. So this, our original integral given to us, star, now becomes what? Now becomes the integral of cos x over 3 plus 2 is now v. So the integral of cos v dx is now what? Dx is now 3 dv. 3 what? dv. So this is equal to, 3 is a constant. I can take it out of the integral sign. I have 3 integral of cos v with respect to v. And when we started, we had shown also again here that when we integrate cos x dx, we get sine x plus c. In a similar manner also, if we integrate cos v, we get what? We get sine v plus c. But recall again that we're not given anything like v in the original, problem. We're the one that we introduced v to be x over 3 plus 2. So we shall go back. So this gives us 3 sine, what is v? Our v is x over 3 plus 2. So sine x over 3 plus 2 plus our constant c of integration. So I want to take the last problem. So we have the integral of sec squared into 4x minus 6 with respect to x to integrate this. So we also see here a function that has in another function. So we have, let say u again be 4x minus 6. We differentiate with respect to x. We have du over dx is equal to what? 4. So you can say 4 over 1. So we now make the x the subject of the equation again. We have what? Dx times 4 is 4 dx equal to du times 1 is what? Is du. To make the x stand alone, we divide both sides by 4, right? So we have dx equal to du over what? Over 4. So our original problem now becomes what? Now becomes the integral of sec squared 4x minus 6 is u. Sec squared u dx. What is dx? Our dx is now du over 4. Du divided by what? 4. So we can take 1 over 4 out as a constant. So we have 1 over 4 integral of sec squared u with respect to u. So what do we recall again? We had said initially here that if y is tan x, dy dx is sec squared x. So the integral of sec squared x is what? Tan x plus c. In a similar manner, we have that the integral of sec squared u should be what? Should be tan squared u plus c. Since in our original problem, we're not given u, we said let u be 4x minus 6. So we return the value of u to be what? 1 over 4 tan squared. What is u? u is 4x minus 6 plus c. So that is it. In our next video, we shall continue with the integration of trigonometric functions. But this time, we shall deal with cases where we have to introduce, some trigonometric identities. So till then, like this video, make comments, share this video, and also do not forget to subscribe to this YouTube channel. Bye.